In April 2029, an asteroid the size of the Eiffel Tower is going to fly past Earth, so close that it will pass below the orbits of our own satellites. You will be able to see it moving across the night sky with your naked eye. No telescope, no binoculars, just your eyes, watching a 340-meter rock travel at 30 kilometers per second, roughly 32,000 kilometers above your head. Here is what we already know about this event. Earth's gravity is going to physically reshape the asteroid as it passes, triggering surface quakes and shifting rock across its surface in real time. The same NASA spacecraft that explored asteroid Bennu is already on its way to meet it. And 2 billion people across Europe, Africa, and Asia are going to be able to watch it with naked eyes on the same night. But here's the part most people do not know. When this asteroid was first discovered in 2004, astronomers calculated that it had a roughly 1 in 37 chance of hitting Earth. Not in some distant future, in 2029. In that same year, the viewing party is now scheduled. This is the story of Apophis, the asteroid named after the Egyptian god of chaos, and what is going to happen when it arrives. June 19, 2004. 3 astronomers at Kitt Peak National Observatory in Arizona were doing what planetary scientists do every night, scanning the sky for objects whose orbits bring them close to Earth. What they found would set off the most alarming period in modern planetary defense history. The object was cataloged, tracked, and fed into orbital calculation models at observatories around the world. And within months, the numbers came back deeply unsettling. This asteroid had approximately a 2.7% chance of hitting Earth on April 13, 2029. That is roughly 1 in 37. That might sound small, but imagine being told there is a 1 in 37 chance your house is going to be demolished next Tuesday. You would not ignore that number. Nobody did. For context, no asteroid of this size had ever been assigned a collision probability anywhere near that high. The object immediately reached a rating of 4 out of 10 on the Torino scale. Think of it as the International Asteroid Threat Alert System, similar to hurricane categories. And that score had never been reached before. Ever. The news leaked before NASA could issue an official statement. Headlines around the world ran within hours. Planetary scientists were giving interviews at midnight. People were genuinely afraid. And for several weeks, nobody could definitively tell them they were wrong to be. The asteroid was named Apophis, after the ancient Egyptian serpent god of chaos and destruction. Given the circumstances, the name seemed appropriate. Now, here is where the story takes its first unexpected turn. Over the following months, better observations came in. More radar data, more precise tracking, and gradually, the 2029 impact probability was revised down, then further down, and eventually eliminated entirely. The collective relief was enormous. Apophis was not going to hit Earth in 2029. But the very same calculations that ruled out the 2029 impact revealed something else that nobody had expected. During its 2029 flyby, Apophis was going to pass extraordinarily close to Earth. Not dangerous close, but historically, jaw-droppingly close. The refined trajectory showed it would fly within approximately 32,000 kilometers of our planet's surface. The Moon, for comparison, sits about 384,000 kilometers away. Apophis is going to pass at 1/12 of the Moon's distance. Our communications and weather satellites in geostationary orbit, the ones carrying your TV signal and GPS data, sit at around 36,000 kilometers up. Apophis will fly below many of them. This will be the closest approach to Earth by any asteroid of this size ever recorded in human history. And then, just as scientists thought the drama was over, a new problem surfaced. Even with 2029 ruled out, a small but non-zero probability of a 2036 collision remained in the models. The concern was specific. During the 2029 flyby, Earth's gravity was going to pull on Apophis and bend its orbit. And if the asteroid passed through a narrow corridor in space, a corridor only about 600 meters wide, which scientists call a gravitational keyhole, think of it as a doorway in space that leads directly to a collision course. The altered trajectory would put Apophis on a direct path to Earth 7 years later. That scenario sat unresolved for years, until 2021, when radar observations finally closed the door on it completely. Apophis poses no threat to Earth for at least the next 100 years. But the event itself, that extraordinary close pass in April 2029, is still coming. And what it is going to look like is something almost no one has fully described. On the evening of April 13, 2029, around 2 billion people across Europe, Africa, and parts of Asia will be able to step outside, look up at a clear sky, and see Apophis moving. Visibly drifting across the constellation Cancer, getting brighter as it approaches and then fading as it pulls away. At its peak brightness, it will glow at about magnitude 3, roughly as bright as the stars in the Little Dipper. And according to NASA, it will cross the width of the full moon in roughly a minute. If you watch it for 5 minutes, you will be able to see it shift position with your bare eyes. That is an Eiffel Tower-sized boulder moving at 30 kilometers per second, about 32,000 kilometers above your head. To put that distance in perspective, the International Space Station orbits at about 400 kilometers up. Commercial aircraft fly at around 12 kilometers. The satellite carrying your GPS signal right now is at 20,000 kilometers. Apophis is going to fly past at 32,000 kilometers, in a region of space where your communication satellites live. Now here is what makes this even more interesting than the spectacle itself. Earth's gravity is not just going to bend Apophis's flight path as it passes. It is going to physically change the asteroid itself. And scientists have never watched this happen to an object this size, up close, in real time. Here is how it works. When any large object gets close to a planet, the gravity on the near side of that object pulls harder than the gravity on the far side. That difference in pull, called a tidal force, the same mechanism responsible for Earth's ocean tides, creates stress inside the object. For a rigid solid rock, that stress might do very little. But most asteroids are not rigid solid rocks. Many of them are loosely held together collections of rubble, like a pile of gravel floating in space, held together more by their own weak gravity than by any structural strength. When Apophis passes within 32,000 kilometers of Earth, those tidal forces are expected to alter how fast it spins on its axis. They may trigger surface quakes. Imagine moonquakes, but on an asteroid. They may cause small landslides that shift material across its surface. Scientists have never observed a large asteroid undergo this process up close. Apophis is going to give them a front row seat. And then, just to make absolutely sure nothing is missed, NASA is sending a spacecraft. If you watch the video on this channel about asteroid Bennu, I will link it here, you already know the spacecraft OSIRIS-REx. It flew to Bennu, hovered meters above its surface, collected a sample of material that was 4.5 billion years old, and returned it to Earth in September 2023. One of the most technically complex missions in NASA's history. After delivering that sample capsule to Earth, the spacecraft was still in excellent working order. It had fuel remaining, functioning instruments, and a capable team behind it. NASA's decision was straightforward: give it a new mission. They renamed it OSIRIS-APEX, short for Apophis Explorer, and redirected it toward its new target. The same spacecraft that studied the building blocks of life inside asteroid Bennu is now on its way to the most closely watched asteroid flyby in human history. The mission plan is ambitious. OSIRIS-APEX will arrive at Apophis just after the close Earth flyby and begin studying in detail exactly how Earth's gravity has changed it, how its spin has shifted, what has moved on its surface, what the tidal stress event actually did. And then, in one of the more unusual maneuvers ever planned for a spacecraft, it will dip toward the asteroid's surface and fire its engines at the ground, blasting loose rocks and dust away to expose what is just below, essentially peeling back a layer of the asteroid to see what is underneath. Europe is also sending a spacecraft. The European Space Agency's Ramses mission, Rapid Apophis mission for space safety, will fly alongside Apophis during the flyby itself, studying the interaction between the asteroid and Earth's gravity as it happens in real time. 2 spacecraft, 1 asteroid, 1 extraordinary event. Apophis is not going to hit Earth. We have established that clearly. But the reason planetary scientists are treating this flyby as more than just a scientific opportunity is because of what an object like this would actually do if one on a similar trajectory were aimed at us. A 340-meter asteroid impact would not end civilization. The object that killed the dinosaurs 66 million years ago was roughly 10 to 15 kilometers across, about 40 times larger. But a 340-meter impact would cause destruction on a scale that puts it among the worst disasters in recorded human history. The energy released would be equivalent to several thousand nuclear weapons detonated at once. The impact itself would create a crater several kilometers wide. The resulting fires, shockwaves, and debris would devastate everything within several hundred kilometers. For context, in 1908, an object estimated at about 50 meters across, roughly 1/7 the size of Apophis, exploded in the atmosphere above Siberia. It flattened approximately 2,000 square kilometers of forest, an area the size of a major metropolitan region, without ever hitting the ground. In 2013, a 20-meter fragment exploded over the Russian city of Chelyabinsk. The shockwave alone injured over 1,500 people and blew out windows across hundreds of square kilometers. That object was never detected before it arrived. It came from the direction of the sun, hidden in the glare, and appeared without warning. Now imagine scaling either of those events up to 340 meters. If such an object struck the ocean, which covers about 70% of Earth's surface, it would generate tsunamis reaching coastlines thousands of kilometers away. If it struck near a populated area, the immediate death toll could reach into the millions. This is why every space agency on the planet is treating the 2029 Apophis flyby as the most important planetary defense exercise humanity has ever attempted. There are currently more than 2,000 known potentially hazardous asteroids, objects large enough to cause serious damage, whose orbits bring them close enough to Earth to be a concern. Most of them present no near-term threat, but the word known is doing a lot of work in that sentence. Our ability to detect objects approaching from the direction of the sun remains limited, as Chelyabinsk demonstrated in 2013. And even for objects we do track, predicting their exact trajectories decades into the future is enormously difficult, partly because something as subtle as sunlight itself gradually pushes asteroids off course over long periods of time. Apophis is a perfect test case for improving all of that. By watching exactly how Earth's gravity reshapes its trajectory and surface in 2029, scientists will refine the models they use to predict asteroid behavior for every other near-Earth object we are tracking. By measuring how its spin changes in real time, they will learn things about asteroid mechanics that cannot be replicated in any laboratory on Earth. And by having both OSIRIS-APEX and Ramses at the scene simultaneously, they will get a complete picture of a tidal reshaping event, before, during, and after. The only asteroid deflection technique tested at full scale to date is the DART mission in 2022, which successfully altered the orbit of a small asteroid by flying a spacecraft directly into it at high speed. That test confirmed that kinetic deflection works in principle, but how well it works depends heavily on what the target asteroid is actually made of. A loosely packed rubble pile absorbs the impact differently than a solid rock. OSIRIS-APEX's observations of Apophis are designed to answer that question, to determine its internal structure so future deflection missions can be properly designed. In 2004, this asteroid had a 1 in 37 chance of ending a large portion of human civilization. In 2029, that same asteroid is going to become the most scientifically valuable flyby event in recorded history, watched by 2 spacecraft, tracked by hundreds of ground-based observatories, and visible to the naked eye from half the planet. Objects of the size of Apophis come this close to Earth approximately once every 1,000 years on average. No one knew the last time something like this happened was coming. This time, we do. And the data we collect from this encounter is going to fundamentally change how prepared we are when the next one arrives. Because eventually, one will arrive that is not just passing by. April 13th, 2029. Mark it in your calendar. Clear sky or not, something extraordinary is going to happen that night.